Okay, so today we're going to be talking about basically two methods for solving quadratics. The methods we've already spoken about have been graphing and looking for the real answers, the real zeros to an equation, a quadratic equation, by saying that we're saying, can we see if and where it crosses the x-axis? If it doesn't cross the x-axis, well, then there would be no real solution. So you have to use another method to find the imaginary or complex solutions to that. And so sometimes it crosses just in one point. And so there would be just one solution, one real solution to that. And that's the only solution for a parabola. And if you get something like that, when you solve it by factoring, you will notice that something like x squared plus 6x plus 9 equals 0. When you factor it, you're going to get x plus 3 and x plus 3. And because the factors are duplicated, then you're just going to get one answer, x equals -3. So a graph like that would be touching the x-axis only in one spot at -3. Okay, so the real answers coincide with the zeros or the x-intercepts of that function. And so, okay, so the second method that we talked about was factoring. Okay, so we graph to find the zeros, we factor to find the zeros, and then the third one that we talked about a little bit was the square root property. And so if you've got, like, say 2x squared is equal to, say, 50, you can divide both sides by 2, and then you're going to take the square root of the answer here. And you always have to put plus or minus on your answer because both of those will make it true. So x equals plus or minus 5. And even with imaginary numbers, if you had like x squared is equal to -25, you're going to get plus or minus 5i. Okay, so always, always, always when you do the square root property, you're going to put plus or minus on your answer. So I think the next step that we're going to talk about would be using the square root property for a couple more things. It's really kind of a ninja type thing. And you can really use the square root property essentially if you just have x squared, but not x as well. Okay, I've seen people try to solve quadratics. I have x squared and x, to solve it, and it really doesn't work well. So say that you had x squared plus, say, 5x plus 4. You can't solve that by minusing 4 and try to square root it. It doesn't work. Your better choice would be to either graph it or to factor this. This would factor real quickly and then use a zero product property on such a problem. So of the 5 methods, it's looking at your question and saying, what options do I have? What makes sense for this problem? So let's dive into when can you use the square root property? Well, I told you already, if it's just x squared but not x, that is a no-brainer. Go ahead and use it. Okay, so let's go into here and say, okay, so and they talk about that at the top, okay? If you have x squared equals a number, you can take the square root of both sides, and then you can put a plus or minus on your answer, and that will give you the solutions to that problem. And so on this one, if you add 400 to both sides, you get x squared is equal to 400. You can square root both sides, and you get x is equal to plus or minus 20, because that's true. If you take 20 and square it, you get 400. If you take -20 times -20, you also get 400. So put plus or minus on it when you do that. Now, the next one, I told you a minute ago, you can't use the square root property on it, okay? You can't use the square root property on it. And you're like, well, then why are you teaching me the square root property on this one here? And I think the big thing is I need to take you aside here and say, let's look at another question that you may not necessarily realize you could use a square root property on it, but it's incredible. And I've seen it. I've helped my daughter study for the GRE. It's on those kind of questions as well. So say that you had 2, and then you had x plus 3, and you had squared, and then you had plus 1 is equal to, say, I don't know, 13. And you're like, how would I solve this for x? Well, your brain probably says you've got to FOIL out the x plus 3 and then distribute and add the 1 and then bring everything to one side and then solve it. Actually, this kind of question, if you see just one value who is squared, and honestly, it's the weirdest thing ever, this right here counts as just one value that's going to be squared. Okay, so this right here, we're going to try to isolate her, okay? And we're going to say, let's solve it, let's isolate the squared, and then we'll use the square root property. So watch me as we go through here. To get to the x, we're going to minus 1, and then we're going to divide both sides by 2. Okay, so you get a 12, and then you got a 2 here. Again, we're trying to get to x. We could square this out and then distribute it to 2, but that kind of makes more x's. And so when you've got just a binomial squared and your goal is to solve for x, honestly, dividing both sides by 2, you can't distribute into a parenthesis that's squared. You cannot do that. That does not work. You have to square it first and then distribute it. And I don't really want to distribute that. So you get this. Now, watch this. If your goal is to get to x, you got to think about, what is my goal? Okay, what is my goal? I want to get to x. So we can square root both sides as long as we realize, hey, put plus or minus on the right side. So you get x plus 3 equals plus or minus the square root of 6. And then you're like, okay, well then to get x, you're going to subtract 3 from both sides. And you always, always, always shimmy that -3 in front of the square root thing, because then you'll have it in standard form, especially if you've got imaginary numbers. And that's your answer. -3 plus the square root of 6 and -3 subtract the square root of 6. And if you want the decimal equivalent, you could type that in your calculator, but this is plenty fine. So using the square root property only works if you have just a single thing squared, whether it's just an x that's squared or a binomial who has x in it who is squared. So I want you guys to realize this is a really good property to hold on to, but it works in those 2 methods. Well, you're like, well, Kinzer, number 2 doesn't make sense with what you just said. I see x squared and x. Well, the thing is, it's in disguise. It's kind of like Halloween. You know, if somebody shows up to your door and they're in this costume, you may not recognize them. Well, you may not recognize this. And if you don't, guess what? You could bring everything to one side, and if it factors, factor it. And if it doesn't factor, you could graph it, or you could look for, you could use the quadratic formula on it. But I want you to say that, you know, if it says solve by square roots, look, it's going to have a way that you can do this. And what that means is this. The left side perhaps factors into a perfect square trinomial. What do you mean, woman? What I mean is this. A square, as you know, is a shape that has 2 sides that are equal in length. They're congruent. A perfect square trinomial has a lot of that going on there. Okay, first of all, the first and last terms of this trinomial are going to be perfect squares. Also, when you factor it, it's going to make 2 parentheses, 2 factors who are identical, just like the sides of a square. When you multiply them together, you get the area, but both of these sides are equal. So a perfect square trinomial not only has perfect squares for a and c, the first and last terms, but also when you factor it, your factors will be identical. And so if you factor this, you get x and x, and you're going to get -4 and -4. You see that? Rainbow makes -8 in the middle. That is true. So if the left side of your quadratic factors into perfect square trinomials, meaning the factors will be equal to each other, you can compress this into x plus 4. You're like, why would I notice? I don't know, honestly. If you happen to notice, go with it. If not, you're going to use a different method. But if I tell you to try to use this method, this is what I mean. Factor the left side, and then you're going to get something you can do the square root property on. Okay, so how would you get x by itself? Well, we're not going to multiply it out again. That kind of makes more x's. They kind of explode. But we can do the square root property when you just have a single binomial or x that's squared. And so we can square root both sides as long as we remember that the right side becomes plus or minus 7 and the left side is x minus 4. And then if you want to solve this, you're going to plus 4 both sides. So you plus 4 both sides, and you get x is equal to 2 different things. 4 plus 7 and 4 minus 7. So that means your answer for x would be x is equal to 11. And x is also equal to -3. So those would be your solutions to this problem. You would get the same answer if you held everything to one side and graphed it. You would get the same answer if you held everything to one side and factored it, if it does. You would get the same answer if you did the quadratic formula by holding everything to one side. And so there's options for this, but I want you to see sometimes you can do the square root property on things that don't necessarily look like they might be candidates for such a thing. I mean, the golden type of square root property is if it just has a single value squared. Okay, and so the next one, again, if the left side factors into 2 identical factors, well, then you can compress them and use the square root property. Notice A and C are perfect squares here. You see that? They're both 4 and 9. So we can try, it's worth trying, okay, because it's a really golden method to do. And so if I say, please do this, okay, try it. Okay, the factors of a perfect square trinomial will be their square root, so 2x and 2x, and then 3 and 3. And notice they match. If you check it, it does make 9. The rainbow makes 6 and 6x, 6x and 6x, which is 12x. So you can compress this into 2x plus 3, quantity squared equals negative 16. Well, so this is a good candidate for doing the square root property. So square root both sides. When you square root the right, you're going to do plus or minus. And so plus or minus, and notice this is square root of 16, so it's going to be 4i. And then on the left side, you get 2x plus 3. Now here we got to be a little gentle, and this is based on algebra 1 skills, but with a big kid, algebra 2 notch. And so to get x by itself, you're going to subtract 3 from both sides, shimmy it in front, okay? So you get 2x is equal to negative 3 plus or minus 4i, and then we've got to divide each term by 2. Okay, so divide each term by 2. Remember to put the real number first and the imaginary number second. So your final answer would be negative 3/2 plus or minus 2i. That second fraction reduces. So real number then imaginary, that's a complex result. There are 2 solutions, negative 3/2 plus 2i and negative 3/2 minus 2i. Those are our 2 solutions to that problem. So I want you guys to be able to say, hey, we can use the square root property on things that have just a single value squared. Okay, so let's keep moving on this. There's something called completing the square. It's kind of like going to Build-A-Bear. Okay, where, there isn't a perfect square trinomial in this, but we can build one. And then when we walk out of the store, we're going to have a perfect square trinomial. Okay, and so you're like, what is that? Well, on the left side of this, I don't see a perfect square trinomial. And if I move the 9 there, it is not going to be a perfect square trinomial. And if you try to factor it, it doesn't make 2 factors that match each other. Okay, if you brought everything to one side and factored it, the factors will not be identical. So that does not count as a perfect square trinomial. And so I think the big thing would be, can we make it one? Okay, and so the way you make it one, it would be first thing. First of all, you need it to have no coefficient in front of the x squared. So if it does have a coefficient in front of the x squared, you have to divide everybody, all 3 terms or all 4 terms by that value to get rid of that coefficient. Even if the coefficient's a perfect square, you don't want one there. And even if it's negative, you have to divide by negative to get rid of that. So the first term has to have a coefficient of positive 1 in front of x squared. The second thing is you've got to build your C term to make it to be a perfect square trinomial. Okay, the problem with the current problem is that you've got x squared minus 8x, and then if you brought it all to one side equals 9, if you factor that, which is a valid method, you would do 1 times 9. And notice these 2 factors don't match, do they? They're not a perfect square trinomial because the factors are not identical, like a square has 2 sides that are identical or congruent. And so how you make it into a perfect square trinomial is you look at the B term and it's all about the B term. Okay, it is. To find the vertex, you guys do opposite of B over 2A. To make the new value for C, it's a magical value for C, you take B divided by 2 and then you square it. That will make your new value for C. Okay, so B in this case is negative 8. So you take negative 8 over 2 and then you square it. So negative 8 divided by 2 is negative 4. Negative 4 times negative 4 is positive 16. Okay, and so that would be the new value to build a perfect square trinomial on the left side of your equation. And so you're allowed in math to add the same number to both sides of an equation. So if I want the C term to be 16, well, then I'm going to add it to both sides because I don't want the 9 to join it. Okay, there are multiple ways to think about it, but the easiest way and the most traditional way is just to focus on the left and let the right side just kind of fend for itself. So 9 and 16 make 25. Okay, and so again, the right side can be whatever number it needs to be. And we'll worry about him later. So the biggest thing is to build a perfect square trinomial on the left by doing B over 2 and squaring it. And C will always be a positive value because you're squaring it, positive or negative makes a positive. And then when you factor the left side, you're going to get a perfect square trinomial because you built it on purpose. You're like, oh my heavens, I'm so surprised. This works to multiply back to make the original problem. And because they're identical, you can build a binomial who's squared, compress it together and equals 25. Now we can use a square root property. And so we square root both sides, make sure you put plus or minus on the right. And so you get x minus 4 equals plus or minus 5. And then to solve for x, you're going to plus 4, shimmy it in front of that plus or minus. And 4 plus or minus 5 gives you 4 plus 5 on the top is 9. And then on the bottom, 4 minus 5 is negative 1. And so those were the same answers as if you would have gotten with factoring. And truthfully, if it factors, that would be the way to go. But we're building these skills to say, hey, I know you can do this by graphing, by factoring, by completing the square sometimes. But can you practice doing the completing the square method just so you get good at it? Because there are some problems that will not factor or that will not solve by graphing very well. And so, because they're imaginary. And so we can find those answers by using completing the square. And I would mostly use this method if your B term is even, because if you have to divide it by 2 and square it, I don't like to divide odd numbers by 2 and then square them very much. Okay, if I have a calculator, it's fine. And so you get to kind of choose sometimes, but sometimes I'm going to ask you to do this. Okay, so the first thing is divide by the coefficient in front of x squared if there is one. Second thing is, if there is a C term already, get them out of the way, move them to the other side. The third thing is, hey, let's find the new value for C that will build a perfect square trinomial on the left side of our equation. So we're going to do 14 divided by 2, and we're going to square it. And so that's going to be 7 squared, which is 49. It will always be positive. So we're going to add 49 to both sides of our equation because that's how you do it. If you only add it to one, you kind of have issues. Okay, your answer will not be true. It'll be kind of wrong. Okay, so because we divided by the coefficient of x, because we moved the C term to the other side, because we picked a new value of C, a magical value, we're going to be able to factor the left side into 2 factors that will be the same, just like a square has 2 factors that multiply, that are equal to multiply to make their area. So this is plus 7 and plus 7. So it's x plus 7 parentheses squared equals 25. All right, so well, this is turning out cute again. They don't always turn out cute on the right. Sometimes you'll have a square root of something stupid or an imagined number on the right, and that's okay. Okay, we're just practicing to build the concepts. So to get x by itself, we're going to square root both sides, and we put plus or minus on the right. Again, the problem on the right is sometimes good and sometimes mean. And then we're going to minus 7 from both sides. So you get negative 7 plus 5 and negative 7 minus 5, and that would be negative 2. And then x is also equal to negative 12. So those are our answers for the problem. And so if you graphed it, you'd see that's where they cross the x-axis. Okay, so let's keep on trucking. Number 6, okay, again, divide by x, coefficient of x squared if there is one. We need to move the value for C over to the other side because this obviously is not a perfect square trinomial as it stands. So move the 29 to the other side, but you can minus 29, so you get x squared minus 4x equals 29, negative 29, pardon me, because you have to subtract it. And let's pick a new value for C. Let's do negative 4 over 2, b over 2, and square it. So that would be 2 squared, or negative 2 squared, which is 4. So we're going to plus 4 to both sides of the equation. And then, because otherwise it won't work, so you do x minus 2 and x minus 2. That works to factor that. So it's x minus 2 parentheses squared equals negative 25. Ooh, look at us moving up in the world. When we do the square root property, we're going to get an imaginary number, and we also have to do plus or minus. So you get x minus 2 equals plus or minus, and that's 5i. And then we're going to plus 2 to both sides. So you get x is equal to 2 plus or minus 5i. Always put the real number first. And so 2 plus 5i is one answer, and 2 minus 5i is the other solution. If you graphed it, you would not see those answers, would you? You cannot find imaginary solutions by graphing. Okay, it doesn't work that way. And so, and you couldn't do the square root property because it's x squared and x. So building a perfect square trinomial on the left is a really valid skill. Okay, so the next one. Notice there is a coefficient, okay, and you're like, okay, this is disgusting. So we have to divide everybody by 4. So divide everybody by 4, and this is going to make a disgusting fraction, so try not to cry too hard. So you get x squared minus 3x, and then we're going to also move this to the other side. So that equals 27/4. Okay, so I'm going to add it to go over there. And then we have to, and then it gets worse. Do you see how the b term is odd? You're like, I love this. Okay, well, let's take b over 2 and square it. I think sometimes fractions are better than decimals. I don't care which one you use. Fractions and decimals are equals. As long as you don't round off, you're going to get 9/4. So you got to add it to both sides. Cute. Okay. And then we factor the left. It's going to be x minus 3/2. And if you rainbow it out, you do get -3. Okay. Negative 3/2 and negative 3/2 make negative 6/2, which is -3. Okay, so it's kind of disgusting. Minus 3/2 squared equals, and then you put those together and you're going to get 36/4. That's not too bad. So when we do the square root property, the right side is going to be just plus or minus 6 halves, which is plus or minus 3. But I think we're going to leave it as a fraction just because we've got some other fractions running around screaming. So you get x minus 3 halves is equal to plus or minus 6 halves. And then we're going to solve this by doing x is equal to 3 halves plus or minus 6 halves. So 3 plus 6 halves is going to be 9 halves. And 3 halves minus 6 halves is negative 3 halves. Okay, and so those are the two answers there. And I think the big thing is I would not necessarily pick to do number 7 that way. I probably would do the quadratic formula, but honestly, it's not terrible. Okay, the fractions, if there are some, tend to not end up working out as bad as they possibly could. Okay, moving forward, let's talk about vertex form. Vertex form is going to be, standard form for graphing a parabola is this right here, okay? Oh, I don't know why I picked gray, but there it is. And then to find the middle, you've got to do opposite of b over 2a to find the vertex, okay? And so then you'd plot some points and you'd graph it, okay? Another example could be this, okay? And if you're graphing this, you cannot divide everybody by 2 because then you'd have y over 2 on the left. So if I say, hey, graph this, then I would say you need to graph it as is, okay? If I said solve by graphing, you could divide everybody by 2 on the second one. And so the thing is, to get it into vertex form is lovely because from vertex form, you can see the vertex, you can see the vertical stretch, you can see from the origin which way does your graph move to get to its new location. Okay, so let's think about an example. If I've got y is equal to 3 and then x minus 2 squared and then plus 1, this graph from its parent parabola, okay, is going to be moved, it's a vertical stretch by 3, it's going to be right 2 and up 1, okay? And then it's going to be happy because the coefficient's 3. And if you plugged in values, like if you made a table, you'd be like, let's start with a vertex. It starts at 2, 1. And then you could pick some x values on each side, or you could say, hey, guess what? I know the normal parabola goes over 1 and up 1. Well, this is over 1, but up, say, 3 times that much, okay? And so it's normally over 2 and then up 4, well, it's going to be up 3 times as much. So it's going to be up 12. And so you can get a really good read on a parabola if it's in vertex form. And so sometimes we're going to convert from standard form to vertex form. If you wanted to get from vertex form back to standard form, you would have to FOIL out this binomial, then distribute a 3, and then plus 1. And you could do that as well. But that's less normal to do because vertex form is so handy. Okay. So let's look at it says put this in vertex form. There are multiple ways to do it, but I feel like the most intuitive way to do this is to say, hey, it says put it in vertex form. Well, find the vertex and then put it in that form, okay? And the formula is, and here's a good example of like, hey, the vertex is here, the opposite of h, and this is going to be k. So the formula is going to be y is equal to a, and a is that coefficient here. It's also this number right here, so they match. And it's going to be x minus h squared and then plus k. Remember, the vertex is hk. And you know, if you see a plus 3 here, that means left 3. Okay, and that means the x coordinate is negative 3. And then the k stays the same. So hk is going to be the vertex of that problem. So to find the vertex here, so to find the vertex, you're going to do opposite of b over 2a. So you're going to do 10 over 2 times 1. And so that's going to be 5. So the x coordinate of your vertex is 5. If you plug that into your function, you get 25 minus 50. That's negative 25 plus 21. It's going to give you negative 4. So that's your vertex. And so if you want to, and over here, look at your a term is 1. Okay, a is 1. So when we put this into our, that just kind of got rid of it, into this basic form, okay, vertex form, we're going to use a, h, and k to plug it in. Okay, so a is 1. So when we write this, we're going to write y is equal to 1, or you can leave it off, okay? And it's x minus 5, okay, and then squared. So x minus 5 squared, and then subtract 4. Because remember, it's the opposite of the h, the horizontal movement, and then it's going to be up k. So this has a minus in the problem. And so that's going to be it. And the thing is, it's going to be a minimum, and the vertex is here. Okay, so the min is going to be -4. It's going to be a happy parabola. It's going to be look right 5 and down 4 with a vertical stretch of 1. Okay, so you can kind of envision what this parabola will look like. In this problem, you can see that this value is 3. A is 3. And so when we write our final answer, we need to put that 3 as the coefficient. To find the vertex, you do the opposite of B over 2 times A. And that's going to be 6 over 6, which is 1. So your vertex is going to be 1, and we plug in 1. 1 squared is 1 times 3 is 3. 3 minus 6 is -3, and -7 is -10. So our vertex is going to be this, and that's going to be a min, okay? The min is -10. It's going to be the bottom of our parabola. And so how do we put this in vertex form? Well, we're going to do y is equal to 3, and then x minus 1 squared, and then subtract 10. So you can get a really good read on what this parabola will look like by saying, hey, it's right 1 and down 10. It's going to have a vertical stretch by 3, so over 1 and up 3, and then over 1 more and up 12. That's what your graph will look like. So it's pretty cute how you can transfer between one form and the other if they ask you to do that. Okay, and then the next one is going to be a grumpy parabola, and you can tell that because there's a -2 there. So A is equal to -2. To find the vertex, you're going to do opposite of B over 2 times -2. So you're going to get 14 over -4. So we're going to cry a little bit. It's 7 over 2. Okay, so 14 over 4 is 7 over 2. And so that's your x coordinate. Yes, you'll probably want to use a calculator and plug that in there. But if you plug it in and square it and times by -2, just make sure you put your x in parentheses. I think that's huge. And you can put the whole thing in your calculator. You can just literally do this. Use the fraction key. Or you do 3.5 if it makes you feel better. Because you can use decimals as long as you're not rounding off. And so if you put that in your calculator, you should get 35 halves, or the decimal equivalent, okay? And then when you put this into your function, you do y is equal to -2. Again, bring your a down there. It's going to be a grumpy parabola, vertical stretch by 2 and reflected vertically. It's going to be x minus 7 halves. That's right, 7 halves or 3.5. And then plus 35. So remember, it's x subtract the x coordinate of your vertex and then plus k. And so the vertex is this. It's going to be a max, okay? And so if you plotted that value, it's going to be right 3.5, and then it's going to be up 35 halves. It's going to be grumpy, okay? And so instead of over 1 and down 1, it's going to be over 1 and down 2, okay? And then over 2 and not down 4, but down 8. And so that will give you a pretty good picture of what you've got. And so that would be a max, and the maximum value is 35 halves. Okay, remember the max you talk about is going to be the y coordinate. All right, thank you. Have a good day.